Hi there, my name is Martin Kelson. I'm the author of Scratch for .NET Microframework, and I want to give you a quick walkthrough today on installing and getting started with Scratch for .NET Microframework using the GHI Electronics BrainPad. First thing you'll need to do to get set up is navigate to the Scratch for .NET website at scratch4.net. And the first thing you're going to need is hardware that's compatible with Scratch for .NET. And today that means the GHI Electronics BrainPad. Now we'll be adding some of these other boards within the next few weeks here, but right now we focused mainly on the GHI Electronics BrainPad. So the two pieces of hardware you're going to need are the GHI Electronics BrainPad board and a microbus click USB serial adapter, a UART adapter. Once you have those two, then we need to get some software. There's really only three pieces of software you need to download. You'll need the USB drivers for your board, and right now that probably means you're going to need to install the SDK from GHI Electronics. Navigate to the GHI Electronics website and you'll find their SDK for their board. That'll install all of the USB drivers for you. Then you need the Scratch for .NET gateway and MIT Scratch, the Scratch program itself. Installing the Scratch for .NET gateway just involves clicking on this link on the install page on the software page. You'll see a page that looks like this, and click install. Now, you'll get some warnings. This is new software, and Google isn't recognizing it yet as being a safe piece of software because not too many people have downloaded it. But we'll click on Keep, and then once it's finished downloading, I'll click on the download. It's going to ask if you want to install this software. We're not signing this yet. We haven't got our signing certificate, so you're going to get a few warnings that we don't know who the publisher is. It's me. So it should be safe software. I'm going to go ahead and click install. We'll get this signed in a future version. And then you'll get this little pop-up window. Now this shows in a variety of different colors. I got a red one this time. Just click on, I understand I want to run this app. Click on Run Anyway. And Scratch for .NET devices will show that little pop-up screen saying that it's downloading the firmware and it's downloading a bunch of other files. The Scratch for .NET gateway actually updates itself every time you run it. So you may see a new version pop up here, and you may see notices here that you need to update your firmware. Now we don't currently have any firmware on the board, so I'm going to have to deploy some firmware. It's found the correct board, so it knows I've plugged in my BrainPad, and it knows that it's the BrainPad firmware image that I want to put. Sometimes there'll be more than one choice here if you have a board that can be configured several different ways. If you have any questions about it, you can click on one of these two links to get information about the BrainPad or information about the firmware. Let's bring back the Scratch Gateway. Scratch Gateway is always going to update its firmware images and other libraries and so forth from the cloud. Now you do have to deploy those firmware images, but they'll be down local on your system. So here's my BrainPad with no firmware installed, and here it is with a blank screen. I'm hooked up with the USB cable on the debug deploy, and I also have a USB cable here on the microbus click, and both of those are plugged into my PC. Now I'm going to hit the deploy button here to deploy the latest firmware. And it has deployed the firmware and rebooted the device. And now I'm going to go ahead and close that. It looks like it's not actually finding the device. Oh, there it is. Sometimes it won't find the device. So if you have any problems with it, if it doesn't show what you expect to show, the answer is always just stop the gateway and restart it. There's a lot of plumbing under the covers here, and this is fairly new software, so not everything is perfected. We do run into some conditions where it's not talking to the board correctly, but you should see with these two USB connections, we should see these two lines here. One is the .NET Micro Framework device. This is us talking it through the debug deploy part. And this top row here is us talking it through the serial COM port, and here we're actually talking to the Scratch program that we've deployed onto that board. So once we've got this running, we can set this aside. You could close it. It doesn't have to be up here on the screen. It doesn't really do anything interesting after this point, but it does have to remain running. So let's open up Scratch and do some simple programs. I haven't really planned out anything specific, so we're going to kind of just wing this. What you need to do is start the Scratch program. And now we need to load our template for Scratch for .NET. In order to do that, you click on the File menu, but you have to hold down the Shift key when you click on the File menu in order to get this super secret extra option here, Import Experimental HTTP Extension. Click on that, and then under your Documents folder, Scratch for .NET, you'll find a template file for BrainPad. Select that file. And once you've selected that file, now under More Blocks, you have all of the blocks for talking to the BrainPad. Let's do a really quick, simple program. Let's just put our .NET program start there. And then let's go get a look. And the look, we're just going to say hello. Well, that's not terribly interesting. Let's go back to .NET. And let's look at the current temperature in centigrade. And so now the cat is telling us the current temperature in centigrade. Now I'm in Europe, so that's fine for me, but you probably want to see it in the US in Fahrenheit. So let's look at it in Fahrenheit. There it is in Fahrenheit. So there's a really super simple little program talking to the Scratch board. If I actually want to show you that this is working for real, here's the thermometer. And all I have to do is cover that thermometer with my finger, and you see the temperature go up. I'll take that away. Let's look at the light sensor. So instead, I'll look at the light level, put that in there, and there's this sort of arbitrary number representing the light level, but if I cover up the light sensor, it goes down. I expose the light sensor, it goes up. Well, let's do something a little more interesting. I'll get rid of all of these. Let's put a little if statement in there. Let's put two if statements in. There's one. There's another. We'll go back over here and we'll say if the left button is pressed, do that block. If the right button is pressed, do this block. Let's actually add a third one. Let's do another if statement. Now let's look at the up button. And these are referring to the directional buttons on the pad. On the left side of the pad here you have these arrow buttons. So if the left button is pressed, what I'd like to do is, like I said, I'm kind of winging this. Let's turn the red traffic light on, and let's turn the green traffic light off. And then if the right button is pressed, we're going to turn the red traffic light off and turn the green traffic light on. And let's give that a little test. So the program is always running. Well, I'll fill out this last one here with the up button. Let's do something with our cat there. If the left button is pressed, now let's see, if the right button is pressed, let's turn him to the right 15 degrees. And if the left button is pressed, we're going to turn the cat to the left. And if the up button is pressed, let's switch to a different costume. Alright, let's test our little program. So I press the left button, our traffic light. Oh, we have a bug in our program. I didn't set it to green, so let's say green there. So left button is red on, green off. Right button is red off, green on. Let's give that a try. There's our red. There's our green. So that seems to be working. Now, I'll see that the cat is turning as I hold the button. And if I press the up arrow, the up button, it changes between his different costumes or his different looks. Kind of looks like he's running. All right. Let's do a few other things. One of the other things we can do is play a note through the speaker. So I can play a C5 for a quarter beat, or I can play, let's say, a G5. Way down here, G5. So now we should hear a note when I press my left and right. Not sure if you can hear that. I'll put my mic close. I'll take my word for it. It's making a little noise. A few other things we can do. Let's just test everything. So a few other things we can do. Let's set the bulb color to either fuchsia, a personal favorite of mine, or let's set the bulb color to violet or lime. There's another nice color. Now we see that the light is also changing colors. But you'll notice that there's a little delay. When you're playing a note, the program will actually stop until that note is finished. Now, that's important because if you put a bunch of notes one after the other, you don't want them to play all at the same time. They play one after the other. So your program is going to stop for the duration of that quarter beat. I'm going to pull that out, just because you probably can't hear it anyway. Just pull out those notes. And let's do one more little thing here. Let's move the servo. So if you press the left button, I'm going to move the servo fully one direction to 0 degrees. And if you push the right, I'm going to set the servo angle to be 180. So let's see if that works. I don't know if you can see the servo, but the servo is turning. The lights are changing colors. Everything's doing what it's supposed to do. And there are a few other things you can look at here. One of the things is the accelerometer. I'm just going to show that all these various things work. So let's take a look at the tilt in the X direction. So now as I tilt the board, sometimes that doesn't go in the first try. Let's look at the Y direction. So as I tilt the board in the Y-axis direction, you'll see that go from negative to positive. So there's a positive tilt to the right, negative tilt to the left. And usually the X will wake up after I've done that. There we go. We might have a bug there. I'll have to look at that. But you do get tilt in the X and Y axis there. These boxes that have the little check marks in front of them, you can actually check that and just get a readout at the top of the screen. You don't have to add them to your program, so you can get a direct readout. It's possible for those two because they don't have parameters on them. Anything with a parameter like centigrade and Fahrenheit, you don't get the little checkbox. I want to point out one other useful piece of information here on the scratch display, and that's this little green circle. If I hover over that green circle, you'll see that it says OK. Now, if for any reason we're not talking to the gateway or the gateway is not talking to the board, that'll change. So if I take my Scratch for .NET gateway and I close that program, we'll see that that turns to red. And it says, of course, can't find helper app. So if you unplug your board, that might turn to yellow, which means that it can find the helper app, but the helper app, the gateway, it can't find the board. I don't have a motor hooked up, but you can also set the motor speed from 0 to 100%. And in the future, we'll be adding some more blocks so that you can work with the display here, clear it, draw lines, rectangles, text, and so forth. So that's the end of our quick demo here. I hope you have good fortune with Scratch and Scratch for .NET Micro Framework. Of course, if you have any problems, visit the educational forum on GHI Electronics forum. You can also get to that forum from our website, Scratch for .NET, and then click the forum button, and that will take you to the education forum on GHI. Thank you very much. I'm Martin Kelson. Hope you enjoy the program, and please feel free to post comments, questions, whatever, and we'll see how we can help you out. Thank you very much.